Alright, in this video we're going to look over section 2.4. I'm going to do some review exercises from the assignments from this section. As we're going through these, feel free to use these to do corrections to your work and also to prepare for the quiz that'll be over sections 2.4 and 2.5. I'm going to start with part 1, finding the value of an unknown number. And this will correlate with example 1 in your textbook. This is from page 141, problem number 9. The problem is 2 less than 3 times a number is equal to 14 more than 5 times a number, and it asks you to find that number. The key to this is to figure out how to read the problem, and you want to break that down into pieces. The easiest way that you can do that is locate is. Once you have found is, that's going to be your equal sign, and just focus on separating this problem into 2 pieces. You've got the left side, which will handle 2 less than 3 times a number, and on the right side it'll be 14 more than 5 times the number. Now I'm going to stay consistent, and instead of the number I'm going to put the variable x in. So let's focus on the left side first. 2 less than 3 times a number. Well, that number is x on that side also. So if I have 3 times x, we'll set that up as 3x, and 2 less than that is 3x minus 2. Is equal to means equals. And on the right side, I'm going to have 14 more than 5 times the number. Now 5 times the number is 5x, and I'm going to add 14 to that. Now to find the number, solve your 2-step equation here. We're going to get the x's on one side by taking 3x away from both sides. Let's move over to the right to do that. These will cancel, meaning on the right side of your equal sign you're going to have 5x minus 3x. It will give me 2x here. I'm going to subtract 14 from both sides, which gives me negative 16. When I divide both sides by 2, what I end up with is x equals negative 8, and that is the number that answers your question. So moving on to problem 11 from the same section, same page. It says if 2 is subtracted from a number and this difference is tripled, the result is, now here's where your equals will be. So the problem is split in half right there. Said if 2 is subtracted from a number and this difference is tripled. You want to read that as a parenthesized expression. When 2 is subtracted from a number, I'm going to use x again as the number, so x minus 2. This difference is tripled. That means I'm going to have to multiply that entire expression by 3. Now the result is where my equals go. So there's where my equal sign will go. The result is 6 more than the number. Now I used x as my number, so I'll use x there. 6 more than that is x plus 6. It's important you use parentheses around x minus 2 because it's going to set up distribution. That's going to turn into 3x minus 6 equals x plus 6. Now for solution step, I'm going to take x away from both sides. Let's move up here to the right. On the left side of equals, I have 3x minus x. That gives me 2x. I'm going to combine steps and add 6 to both sides. To clear that negative 6, that would be on my left side. These will cancel, just like these cancel on the right side. And 6 plus 6 is 12. When I divide both sides by my coefficient of x, I get x equals 6. And you found your unknown number in that case. Now your second type of problem involves sums of quantities. I'm going to put problem number 17 up as an example. And this one deals with the number of senators. U.S. Senate had a total of 99 Democrats and Republicans. And this was in 2002-2003. There were 3 more Republicans than Democrats. How many of each were there in the Senate? On this type of problem, it's helpful to start with a key or a legend to set this up. I'm going to put Republicans and Democrats. And my advice is to set your variable as the one that is smallest, the one where there's fewest. It says there's 3 more Republicans than Democrats, meaning Democrats is fewer. If there are 3 more Republicans, then that will be x plus 3. There's another way to set this up with Republicans as x and Democrats as x minus 3, but I don't recommend putting a negative into your problem unless you just don't have a choice to do that. So this statement, there were 3 more Republicans than Democrats, is what set my problem up. This total of 99 is what I'm going to use to create my equation for this. For a total, I'm going to add the number of Democrats and Republicans I had. So Republicans was x plus 3. I'm going to add x, the number of Democrats, and combined there's 99 of them. Once you've done that step, combine like terms. I'm going to add x plus x to give me 2x. Subtract 3 from both sides, and you get 2x equals 96. Divide both sides by 2 to solve for x. You get x is 48. Now plug that number back in over here. So you have 48 Democrats, and add 3 to that to get your number of Republicans. That's 51. Now mentally check your work to be sure that you do have that total of 99 that the problem said you had. 51 plus 48 does give you 99, so you know that you're correct on that. Now the next problem we'll do is a mixture problem, and this is from page 143, problem 24 from your homework, and it is talking about a sheep ranch located in Australia. The number of sheep on the ranch is 8/3 the number of uninvited kangaroos grazing on the pasture land. Together, herds of these 2 animals number 88,000, and it asks how many of each type of animal are on the ranch. I'm going to start with my key again. Let's start with sheep, and then we've got kangaroos. Call those roos today. Now, going back rereading, the number of sheep on the ranch is 8/3 the number of uninvited kangaroos. So what it's doing is multiplying the number of kangaroos by 8/3 to give you the number of sheep. So this first sentence is what sets up my key. The second one, together, herds of these 2 animals number 88,000, that sets up my equation. So I'm going to add the number of kangaroos plus the number of sheep to give me 88,000 total. Now the quickest way of clearing this fraction, which is what you want to do to solve, is to multiply both sides of this equation by 3. When you do that, you'll do 3 times x, plus you'll do 3 times 8/3 x. Don't forget you must also do 3 times 88,000 to get that answer as well. So 3 times x is 3x. 3 times 8/3 x will give you 8x. Because, let's just do that up here on the side. If I do 3 over 1 times 8 over 3x, then I do 24 over 3, which is equal to 8. Or I can cancel my 3's, which is still equal to just the 8. And don't forget your x's there. Now 88,000 times 3, I'm going to do 88 times 3. Do that quickly by hand, 26. So that's 264,000. Combine like terms, 3x plus 8x gives me 11x equals 264,000. Divide both sides by 11. And I need to do 264 divided by 11. If you have a calculator, this will work out a lot easier, but I'm going to get 24. Don't forget that's 24,000. I left the 3 zeros off. So the number of sheep I don't have yet, but the number of kangaroos is 24,000. I'm out of room to answer for sheep. But I need to multiply 24,000 by 8/3. Now, how do you do that? Let's go down here. Let's do 8 over 3 times x, which is 24,000. And we can put that over 1 if we need to. 3 will go into 24 8 times. Now you know that 8 times 8 is 64. Put your 3 zeros after that, and you have 64,000 sheep. If you add up 24,000 kangaroos to 64,000 sheep, you'll get 88,000 total animals, which matches the original information in your problem. The next mixture problem is number 27. In a mixture of concrete, there are 3 pounds of cement mix for each pound of gravel. So already we know that we're comparing the amount of cement to the amount of gravel in a mixture. So let's set that up, get that problem started. If there are 3 pounds of cement mix for each pound of gravel, let's think about how that works. Your cement and your gravel here. Let's do a little T-chart. If there are 3 pounds of cement for 1 pound of gravel, then how much cement would there be for 2 pounds of gravel? I think you'll come up with 6 pretty easily there. If you have 3 pounds of gravel, this is 1 times 3 to give me 3. 2 times 3 gives me 6. 3 times 3, I must get 9. For each pound of gravel, we'll set this as x. I'm going to multiply by 3 to get the amount of cement. Now the mixture contains a total of 140 pounds. I'm going to add together the amount of cement and gravel in that mixture and make that equal to 140. Combine like terms, you'll get 4x is 140, and then divide both sides by 4. X will give you, I believe that's 35 pounds of gravel. Let's verify that quickly by hand. 3 times 4 is 12, leaving me with 20. 20 divided by 4 is 5. So yes, 35 pounds of gravel. And that's all the problem asks for. How many pounds of gravel are there? Now, if you had asked for how many pounds of cement, then you would multiply that total by 3, giving you 105 pounds. So make sure you go back and look at the problem again to be sure you're answering the correct problem. All right, moving on quickly to part 4, parts of a whole problem. Number 31 from page 144 says the U.S. earned 103 medals at the 2004 Summer Olympics in Athens. The number of silver medals earned was 4 more than the number of gold medals. The number of bronze medals earned was 6 less than the number of gold. How many of each kind did the U.S. earn? The first thing you want to determine is what's being compared. In this case, it's the number of silver, gold, and bronze medals earned during the Olympics. You want to figure out which one needs to be your variable, which one is everything based on. It says the number of silver medals earned was 4 more than the number of gold. So it's based on the number of gold medals. The next sentence says the number of bronze medals earned was 6 less than the number of gold medals. I'm going to set gold as x and set the number of silver and bronze medals as a relationship to x. Let's start with silver. The number of silver medals earned was 4 more than the number of gold. If gold is x, then silver would be 4 more, which is x plus 4. The number of bronze was 6 less than gold. So bronze must be gold minus 6. So that's how I set my key up. This is the hardest part of what you're doing right here, is trying to determine how do you do this part. That's the hardest. Solving it should not be the struggle for you. It's setting up the problem correctly. Now, the U.S. earned a total of 103 medals. That sets your equation. If I add the number of silver, gold, and bronze medals up, then I should get 103. So algebraically, let's do x plus 4, which is the number of silver medals, plus x, the number of gold medals, plus x minus 6, the number of bronze medals, and set that equal to 103. I need to combine my like terms. I have x plus another x. That's 3x. Positive 4 minus 6 is negative 2 equals 103. I'm going to add 2 to both sides, giving me 3x equals 105. When I divide both sides by 3, I'll get x equals, and that is 30. Figure that out. 30 and 15. I believe that's 35. Let's check that by hand. 105 divided by 3. 3 goes into 10 3 times. Remainder of 1. Drop your 15 down. And yeah, 35 is verified. So we have 35 gold medals. It asks how many of each kind did the U.S. earn. So I need to go ahead and add 4 to that for the number of silver, which is 39. And subtract 6 from 35 to give me the number of bronze, which should be 29. If you want to do a quick check to make sure you equal 103, you have 39 plus 35 plus 29. When you add those up, you get 103. So your problem is verified. Now part 5, angle problems. On page 105, this is problem number 35. It says the sum of the measures of the angles of any triangle is 180 degrees. In triangle ABC, angles A and B have the same measure. Well, the angle of, the measure of angle C is 60 larger than each of A and B. What are the measures of the angles? It's very hard to do these without having some sort of illustration. So let's just put a triangle up there. We'll call this A and this B and this C. It doesn't have to be proportional. It doesn't have to be correct based on angle measures because you don't know them yet. You do know the total is 180. I'm marking this A, B, and C. I do have a way of keeping everything in track though. It says angles A and B have the same measure. I'm going to go ahead and put an X in both A and B. C is 60 degrees larger than either one of those. C has to be X plus 60. Now once you get that set up, your total is 180, so you have X, which is angle A, plus X, which is angle B, those are the same, plus X plus 60, which is angle C. Let's set that equal to 180 degrees. Combined like terms, you're going to have 3x. I'm going to go ahead and subtract 60 from both sides, giving me 3x equals 120. When you divide both sides by 3, 3 goes into 12 4 times, so x has to be 40. It asks what are the measures of all three angles. Well, angle A and B equal 40 degrees each. Angle C is 40 plus 60, which is 100 degrees. So make sure you answer that problem as it's asked. If you have room in a diagram, you can also answer it in a diagram. All right, a couple more angle problems. We're talking about supplement versus complement. Now, supplementary angles, we've been talking about in class, and your textbook covers it. The supplementary angles can be found by doing 180 degrees minus x. If x is the angle you're talking about, 180 minus x is its supplement. The complementary angle is 90 minus x. Make sure you keep those expressions in mind. Your angle will always be x. So for 43, it says find the measure of an angle whose supplement measures, or supplement equals 39 degrees more than twice its complement. Don't let the wording confuse you. You actually don't need any of this. I'm worried about supplement. In place of supplement, you'll put this 180 minus x. Let's just drop that in place. 180 minus x measures equals 39 degrees more than, so I'm going to add 39 to something, twice its complement. That's going to be 2 times this amount over here, 90 minus x. Now, to solve that out, you're going to do 180 minus x. Make sure you distribute. You need that in parentheses. 180 minus 2x plus 39. I'm going to stop right there. I'll let you solve that out. Again, solving equations shouldn't be what's holding you back from this. The setup is the hardest part. Moving to problem 45 on page 145. Just a little bit more complex. Find the measure of an angle such that the difference between the measures of its supplement and 3 times its complement is 10 degrees. I don't need to find the measure of. I want an angle in which the difference, that's a subtraction problem, between the supplement, I don't need this, the supplement is 180 minus x, that's what this will be, and 3 times its complement, that's going to be my subtraction problem. 3 times its complement, that's going to be 3 times 90 minus x is, that's where my equal sign goes, equals 10. Be careful when you distribute this negative 3 out. A common mistake is to miss that double negative. You got negative 3 times 90, which is negative 270. Then negative 3 times negative x is plus 3x equals 10. When you solve for that, you're going to find x, which is the angle you're looking for. I'm going to let you solve that out, but there's your setup, which is the hardest part of that. Okay, the last type of word problems that you have in section 2.4 are consecutive integer problems. I want to do a couple of these, actually 3 of these. I'm going to start at 49. It says 2 pages that are back to back in a textbook. When you add those page numbers together, you get 293. Now, consecutive integers, I'm dealing with 2 of them right now. If the first one is x and the second one is x plus 1, and you think consecutive just means that they go in a row, like 3, 4, 5, 6, they're all consecutive. If x is 3, then the second one would be 3 plus 1, which is 4. So this is how you set up those problems. I have a total of 293. When I add the first and second numbers up, this is my equation. Combine like terms. X plus x is 2x. Subtract 1 from both sides. I get 2x is 292. Divide by 2. Solve the equation. And you get 146. Now, don't stop there. You ask, what are the page numbers? I need to take this 146 and put it over here. So x is 146. If I add 1 to it, I get 147. Here are your 2 page numbers, 146 and 147. Another consecutive integer problem. A big thing I want you to keep in mind on this is this says consecutive even integers, and that's an important difference for the previous problem. Even integers are 2, 4, 6, 8. You have to add 2 to get to the next one, not just 1. So keep that in mind as you do your work on these. So let's find 2 consecutive even integers. So the first one is always x. And the second one, since I have a skip of 2, will be x plus 2. So find 2 so that the smaller added to 3 times the larger gives a sum of 46. I need to figure out and understand which one is smaller and larger. Obviously, the second one will be bigger because you're adding 2 to whatever this x is. So this is my small one. This is my large one. Kind of helps to write that in when you set up your key or legend on the problem. So the smaller added to 3 times the larger gives a sum of 46. So in other words, equals 46. I'm going to have to be thinking about addition here. Added to, it means addition. The smaller is x. Added to 3 times the larger. Well, the larger is x plus 2. So I have to multiply x plus 2, the entire expression, by 3 to match the problem here. 3 times the larger. Well, the larger is x plus 2. When you distribute this out, you get x plus 3x plus 6 equals 46. Combine like terms, x plus 3x is 4x. Go ahead and subtract 6 from both sides. 4x is 40. So x is 10. Go ahead and use your legend to answer the problem. X is 10. 10 plus 2 is 12. There are your two consecutive even integers. And your last section 2.4 review problem is another consecutive integer problem. Page 146, problem 53, says when the smaller of two consecutive integers is added to 3 times the larger, the result is 43. So again, I'm dealing with two consecutive integers, not even or odd, just two consecutive integers. Erase that mark there. So the first one is x. The second one, I'm still going to have a skip of 1, is going to be x plus 1. Which one is smaller? Well, obviously x is going to be the smaller one, because x plus 1 is going to be bigger than whatever x is. When the smaller is added to, so x plus 3 times the larger, 3 times the larger one is x plus 1. The result is, there's my equal sign, 43. You're going to need to distribute out the 3 to both the x and the 1, combine like terms, and solve that equation for x. Don't forget to answer both the first and second numbers. You'll need both numbers to, miss that entirely. You'll need both numbers to answer that correctly. So make sure it says find the integers, that you're going to answer the small one, you're going to answer the large one. I'm going to let you complete that on your own. So there's your 2.4 review. We're going to move into 2.5 next, looking at geometric formulas and applications of some more word problems. All right, good luck.